Electrical safety must begin with an understanding of its basic elements and specific terminology, two things in which most responders often have a very limited knowledge. Emergency responders often know the answers but can't tell you the whys of electricity. Here are some phrases. I'm sure you've heard them. More importantly, can you tell me why? Let's check. All lines are
energized.
Considered charged unless proven otherwise.
Live until the power company says they're not live anymore.
Live, energized.
Hot.
Did you say hot or live? If you did, you're right. 2, let's try this one. It's not the volts that kill you, it's the
amperage that kills you.
It is the amps that are fixing to come through and give you that vega that you want to throw out there.
It's the amperage.
Did you say amps? Okay, let me ask you another question. Do you know what amps are? Do you know how much amperage?
It doesn't have to be much.
110, consider it the most dangerous.
Very few. I'd say less than 2.
I know it's a small amount. I don't know exactly how much it is.
Remember that a human being can be killed with as low as 1/10 of an amp. Electricity always flows to
ground. Electricity always flows to ground. And if you're the path to ground, whether you're on an aerial ladder, a hose line, an apparatus, and you become the route to ground, the electricity is going to flow through you.
To ground. It's always going to go to ground.
Generally, we assume that the electricity flows to ground.
Did you say ground? Why?
Electricity is basically looking for equilibrium. It's looking to complete its circuit and go to ground instead of being in a state of flux.
Just because of the difference in potential from where the source is to the ground.
Any energized source that has some voltage, and given the opportunity, it will flow to lower voltage. Since the ground represents 0 voltage, any voltage from 12 volts to 500,000 volts will flow to ground. Electricity current always follows the path
Of least resistance.
It follows the lines of least resistance.
Path of least resistance.
Electricity follows the path of least resistance.
I bet you said the path of least resistance. That's a common answer. But you are absolutely wrong. It doesn't follow the path of least resistance. It follows all paths. And I'll prove that to you later on in this session. Okay. Emergency responders must understand the terms and concepts of electrical energy. If they don't understand the dangers, the result can be electrocution. And electrocution is, by definition, death by electricity. Understanding the hazards is the first step in avoiding electrocution and electrical injuries. That's why this training is so important.